Welcome. This is our fourth and final example of determining the intervals of monotonicity for a function. This time we are going to do a function that has an exponential factor in it. Again, it's really a continuation of an earlier example, which means we have done the harder part of the work, which is to find the derivative and then factor to the extent possible. We did this back in slide 52. The derivative of x squared e power negative x factored is x e to the negative x times 2 minus x. Again, the function is always differentiable. The derivative is 0 at x equals 0 and x equals 2. The intervals will be negative infinity to 0, 0 to 2, and 2 to infinity. Again, I'm going to use test values to determine the sign chart. If you do this by counting negatives, you need to remember that e to any power is positive. So the factor e to the negative x doesn't change sign, only the other two factors do. If I use just test values at negative 1, I have negative 1 times 3 times e to the power 1. That's negative times positive, so it's negative. At 1, I have 1 times 2 minus 1 times e to the negative 1. That's product of three positive numbers. That's positive. Remember, e to the negative 1 is still positive. At 3, I have positive times positive. That's negative. So the derivative is negative in the first and third intervals, positive in the middle interval. Since the problem asked where the original function is increasing, I have to determine where the derivative is positive. That's in the middle interval from 0 to 2, and that's where the original function is increasing. This concludes our example, and at this point you should be able to do most examples. One thing I should warn you about is that if you have logarithms or square roots or fourth roots, so on, the domain may not consist of all or most real numbers, so you need to be careful in setting up an interval. If time permits, we will try doing an example like that next time. Bye.